This is R.D. Sharma Solution Class 12th. We are taking exercise 19.27, chapter 19 of indefinite integrals. Now e raised to x sin x cos x. Now we know that sin 2x is 2 sin x and cos x. That this can be applied in this question. So we'll multiply it by 2 and divide it by 2 since it is a constant, so we can take it outside the integral sign. So this I will be equal to half integration of e raised to x and then 2 sin x cos x, we are writing it as sin 2x according to the formula which I just indicated. Now we'll apply ILATE. ILATE is what? Inverse, log, algebra, trigonometry and exponential. So trigonometry will take first because it comes first in ILATE. So we will call it as u, the first function. And the second function will be e raised to x, which is the exponential function. We are calling it as v. An integration of u and v, u multiplied by v, is already known to u integration of v dx minus integration of, then first the differentiation of u, first function, then the integration of the second function, which is integration of v dx, and then we multiply these two and finally we will take the integration. So this will be half. Okay, half I'm just keeping it for a while. I'll introduce it in a bit. Let's do this one. Sin 2x will come first. Integration of e to the power 2x minus integration of first differentiation of sin 2x and then the integration of e to the power 2x again. So e raised to x again dx, and then we'll integrate it again. Now this will be sin 2x only. E raised to x will be e raised to x, and then we will integrate 2x. 2 will differentiate 2x. 2x will be differentiated and 2 will come. That will be in the denominator. Minus integration of, so differentiation of sin 2x is cos 2x, and then 2x will also be differentiated. It will be 2. So this will be 2 cos 2x, and e raised to x will be e raised to x only. So we have to do it. The e raised to x has e raised to x by 2 we have cancelled. Now this whole is another integration. Because we called it as I, let us call it as I1. So I am integrating this I1 separately, then we will put the result in the required place. So I1 is e raised to x cos 2x. Same thing we are going to apply. U will be cos 2x, v will be e raised to x. This I1 will be, so we have cos 2x, integration of e raised to x dx minus integration of, dx is always there, okay? Even if I leave, you can assume that dx will always be there. And cos 2x is minus sin 2x. So negative, I have made the negative as positive. And it will be 2 sin 2x for cos 2x. E raised to x will be e raised to x by 2. This 2 gets again cancelled. I1 is what? E raised to x by 2. This will be cos 2x plus integration of. So this will come again. This is a reincarnation. Because e raised to x sin 2x has come again from where we started. Alright? And this is not actually I, it's actually 2i. Because if you remember, this half was taken, I didn't use it. So it was taken into some temporary storage. Now I am bringing it back. So this will be, it will be 2i actually. So 2i it will be, and this will be e raised to x divided by 2 cos 2x. And this is I1. Now the first term remains like this, e raised to x sin 2x divided by 2 minus. Now all this needs to be multiplied by negative because we are actually placing it in a place where negative is already there in the beginning. So now I've changed the sign and now I'm placing it e raised to x by 2 cos 2x, and this will be negative 2i. Now this half is already there if you remember. So you have to include this half also. This will be 4, this will be 4 and this will be half. I told you that I made this 2i with the equation from where we started, but half was already there because we actually are doing e raised to x sin 2x. So that's why I multiplied it by 2, and this after multiplication 2 has come in the denominator. We have taken 2i here, e raised to x sin 2x minus e raised x cos 2x. Now this 4 is there, so you can just take 4 common. Now I minus I plus I it has become. Now you can take e raised to x common from here. 2 is already there. So you can bring this 2 in the denominator, it will become 8. So you can take 8 common, e raised to x common. Whatever is inside sin 2x minus cos 2x will remain inside. So this will be I. This is plus constant of integration. That is your final result. Now how to do this? So whatever I have explained, this is the way you are going to go about it. And all this English like languages is very important because you are actually making it understand to other person. E raised to x sin x dx. So we'll again apply the isolate here. So in this isolate, sin x will come first function and e raised to x will come as the second function. So this integration will be integration of e raised to x sin x we are doing. So first of all sin x will come in front. Integration of e raised to x minus integration first differentiation of sin x, then the integration of e raised to x, again integration and final integration. So we'll again integrate it again after multiplying. E raised to x will be e raised to x by 2. This will be sin x minus integration d by dx of sin x is cos x. E raised to x will be e raised to x divided by 2. Now we have to integrate it again. This whole has to be integrated again. So let me write it again because we will be dealing the other part differently, means separately. So half I am bringing outside. It will remain as e raised to x cos x. But this is I. Now this is going to be I1. And I will do it separately. So let me do this. I1 will be equal to e raised to x cos x. Again isolate, same thing we are going to do. So cos x, integration of e raised to x minus integration of d by dx of cos x, and then again e raised to x dx. So just u into v integration I am applying. Cos x, e raised to x will be e raised to x by 2 minus d by dx of cos x is negative sin x. So minus minus become plus, so it will be sin x inside the integration sign. E raised to x will be e raised to x by 2. So this I1 has become like this, e raised to x cos x by 2 plus half we are taking outside again. So it will be e raised to x sin x. Now from where we have started? From e raised to x sin x only. You can just write or replace this e raised to x sin x by I. So I am writing the unchanged content and then here I am placing I in place of e raised to x sin x. And since we have a negative half in front, so we need to multiply this negative half before actually putting it in the original equation. Just multiply negative half, again multiply negative half, so it will be 1 by 4. Okay, now we don't have to deal with negative half. We just have to replace it after e raised to x by 2 into sin x. After this we have to place all these content which we have just completed as per I1. So e raised to x cos x by 4. This is negative 1 by 4 I. So you can write it as I by 4. Now this I by 4 can be taken on left. This will be I plus I by 4. So I plus I by 4 will give you what? It will be 5 by 4. 1 plus 1 by 4 will give you 5 by 4. So on the left it's 5 by 4 I. On the right it will be, because I by 4 we have already taken. So you can take this e raised to x common first. And the highest number is what? 4. So e raised to x by 4 you can take common. So the second part will remain like this, cos x only. But from here when we have taken this outside, it will be 2, you have to multiply it by 2. So 2 sin x minus cos x will be there. Now you can just cancel this 4 in the denominator and bring this 5 in the denominator. So I will be equals to e raised to x by 5, because 5 has come downstairs on the right hand side. So e raised to x by 5, then 2 sin x minus cos x and plus a constant of integration. This is your final result. Now how to do this in a formal way? So this is the formal solution which I am presenting you. You can follow this scheme or you can follow what I have told you or what I have indicated. But you understood the logic, right? Now I will again apply isolate here. This is e raised to x sin ax plus b form. So just call this as first function sin 3x plus 1. E raised to x will be the second function. So this I will be equal to, first function is like this, sin 3x plus 1. It remains unchanged. Then so integration of e raised to x dx minus now differentiation of sin 3x plus 1, integration of e raised to x dx. Then all of this being done, then we have to integrate it again. So e raised to x will be e raised to x divided by 2. Sin 3x plus 1 will be sin 3x plus 1 only, because we haven't changed it, minus differentiation of sin will be cos. So cos 3x plus 1 will come. And then we have to differentiate 3x plus 1 also. So 3 will come. Let me differentiate it separately just to make you understand. Cos 3x plus 1, then 3x plus 1 again has to be integrated. That will give you 3. E raised to x will be e raised to x divided by 2. Then we have to integrate this. Now what do you see here? E raised to x divided by 2. We have sin 3x plus 1 minus. Now 3 and 2 you can bring it outside, because you can bring it outside the integration side. So we have e raised to x, then we have cos 3x plus 1, and then behind we have a dx. From here to here, let's call it as I1, and we'll do the I1 separately. I1 is equal to same thing we have to do. So we'll again apply the ILATE. So e raised to x cos 3x has to be integrated here. 3x plus 1. First function is cos 3x plus 1. So first function will come first. Then the integration of e raised to x minus integration of d by dx of cos 3x plus 1. Then integration of e raised to x again. And then this whole will be integrated again. The result will be. So I have I1. This I1 will be equal to cos 3x plus 1. E raised to x will be e raised to x divided by 2 minus integration of differentiation of cos 3x plus 1 will be what? Minus sign. So minus I have made as positive now. Sin 3x plus 1, then 3x plus 1 differentiation will give you 3. Now the integration of e raised to x will be simply e raised to x by 2. This will be e raised to x by 2. So this I1 has become something like this. E raised to x by 2 cos 3x plus 1. Now 3 and 2 we can again bring outside. 1 3 by 2 was already there in I. Now I1 has given us again 1 3 by 2. So this sign is actually, I'm changing just to make it streamline. So e raised to x sin 3x plus 1 dx. Now this is I only. It has taken one more birth. So this e raised to x by 2 cos 3x plus 1 minus 3 by 2, and this whole is I after that. Now there is see, I've just changed the sign because there was a confusion in sign. So I just changed the sign, right? So now we need to multiply it by negative 3 by 2. So multiplying everything by negative 3 by 2 and changing it accordingly. The last term will become 3 by 2, 3 by 2, that will be negative 9 by 4 I. Now just place it here. This I will be equal to e raised to x by 2 sin 3x plus 1 and negative 3 by 4 e raised to x after multiplication of negative 3 by 2. Okay. So e raised to x cos 3x plus 1, and then after that we have negative 9 by 4 I. So this negative 9 by 4 I will be taken on the left. So it will be I plus 9 by 4 I, and that will give you 4 plus 9 by 4, that will be 13 by 4. So 13 by 4 I is equal to, now what you can do here is, you know that e raised to x can be taken as common, and 4 is the highest in the denominator, so you can take that common also. So e raised to x divided by 4, inside this we have sin, okay, when we take this the right part, only 3 will remain. So negative 3 cos 3x plus 1 will come. On the right, since 2 is in the denominator, so you have to multiply it by 2. So 2 e raised to x already taken out, so only sin 3x plus 1 will remain. Now this 4 can be cancelled in the denominator. 13 you can bring downstairs. So the final I will be something like this, e raised to x by 13, and then we have 2 sin 3x plus 1 minus 3 cos 3x plus 1, and finally a constant of integration. That's your final answer. Now how this will be done? This is a complete solution because there was a glitch in negative sign which I told you. So you can just have a reference from here. Now e raised x sin square x. Now it will be possible that you can use sin square x directly, but a better idea is that 2 sin square x is equal to 1 minus cos 2x divided by 2. Sin square x is this one, 1 minus cos 2x divided by 2. So sin square x can be written as 1 minus cos 2x by 2. 2 cos square x is 1 plus cos 2x, as you remember. So this I can be written like this, integration of e raised x 1 minus cos 2x divided by 2, and then this with a dx. Now we will multiply this e raised x inside, and 2 is already there. So integration of e raised x by 2, and first term is e raised x by 2, second term will be e raised x into cos 2x by 2. So e raised x cos 2x, this half you can bring in front. This is your I. Now this is I1. We'll call it as I1, e raised cos 2x. So this I1 will be equal to, we'll apply the ILATE again. This will be cos 2x integration of e raised x minus integration of d by dx of cos 2x integration of e raised x, and 2 integration will be done here. So e raised x will be e raised x only. This will be cos 2x minus integration of cos 2x is negative sin 2x. So sin 2x negative, I have made it as positive. So you have 2 sin 2x e raised x. Now e raised x cos 2x plus 2 integration. Now e raised x sine 2x. Now I am taking it as I1, but since e raised x sine 2x has come up again, so we have to take it in a other way, or you can solve it here only. I'm just, for the sake of explaining, I'm taking it differently, means in a separate way. I2 is sine 2x e raised x. So sine 2x you can take first, integration of e raised x, minus integration of d by dx sine 2x, and then integration of e raised x. So this is e raised x only, sine 2x, minus differentiation of sine 2x will be cos 2x, 2 will also come, e raised x will be e raised x only, along with the dx. Okay, I am missing dx sometime, but don't worry about that. E raised x sine 2x, 2 we can take outside. When you take 2 outside, what do you see? From where we started, it's I1 only. E raised x cos 2x is I1 only, so it will be negative 2 I1. So I2 is consisting of I1, and I2 is actually coming from where? From I1. So this I1 I am writing now, and I am replacing I2 here. So just multiply with 2 and write everything. Multiply 2 with I2 and place it in I1. So e raised x cos 2x plus 2 into I2 will give you 2 into e raised x 2x minus 4i1. Now this I1 you can bring on the left hand side. So just bring it here, I1. So I1 minus 4i1 will become I1 when we bring it on the left hand side, I1 plus 4i1. So it will be 5i1. So 5i1 is equal to, you can take e raised x common. If you want, you can take e raised x common, but you can use it later also. So 1 by 5 will come here because we have to replace I1 in I here. So this will be e raised x by 2 minus half. Inside this, just put this I1. So 1 by 5 e raised x cos 2x plus twice of e raised x sine 2x. And just multiply these with half. Half is already there outside. So it will be 1 by 10 because 1 by 5 was already outside. So 1 by 10 you can just write. So e raised x you can take common. It will be cos 2x plus 2 sine. It's all sine 2x, okay? There is slight change I am doing. Everywhere where I have written sine x, just update it as sine 2x. Now this will be, I will be e raised x you can take outside, divided by 2 minus e raised x by 10. So it will be cos 2x plus 2 sine 2x plus constant of integration. So this is how it has to be done. This is a reference in front of you, okay? And I have broken it in number of parts, but you can do it like that. This will take later, okay?